Cool. Well, thank you very much. Yeah, my name's Josh. This is KUBE-OIDC-PROXY, consistent user identity in multi-cloud. So yeah, after that talk, which is quite good, hopefully I'm not abusing the word multi-cloud or misrepresenting it. But yeah, welcome to my talk. So hopefully, maybe if I pre-tap the slides and preempt it, it'll be in time. So my name's Josh. Yeah, I'm a customer reliability engineer at Jetstack. We're like a Kubernetes company. Me being a customer reliability engineer is basically a SRE, but for our external customers. I'm also work quite a bit in the open source, so cert-manager. You might be familiar with if you use Kubernetes, and of course KUBE-OIDC-PROXY, which I'm going to talk about today. So the agenda today, I'm going to do a bit of introduction, why this tool exists, and how we can solve it for things like multi-cloud. And I'm just going to turn my video off. Some foundations, around authentication, to do with OIDC, Auth, and how we then use it in Kubernetes for authentication authorization. We'll talk a bit about KUBE-OIDC-PROXY, and then hopefully a demo that will work, and some take-home kind of toy that you guys can play with, hopefully, as long as it works. So yeah, cool. So first of all, why does this tool exist, and what problems are we trying to solve? So as we kind of heard about in the previous talk, when working with multi-cloud, specifically with user identity, each cloud kind of has their own bespoke identity management and mechanisms for kind of authenticating to those clouds, and therefore the kind of Kubernetes itself with their kind of managed services. This causes a lot of issues, meaning that your kind of identity between different clouds it isn't the same, and you kind of get lock-in from those clouds. When you kind of build things around the kind of identity on the system, it's difficult to make them portable across the clouds. You also get the issue where you have no integration with your kind of existing systems. So if you're coming from on-premise, for example, and moving to cloud, then you can find it difficult to kind of translate your current identities into the cloud identities. You have inconsistent RBAC, which is Kubernetes permissions configuration, just to the fact that the identities are different across the clouds, and obviously this has caused issues with human error and having kind of inconsistent permission access across those clouds. Not having kind of parity there, and then of course lack of customization with using these managed Kubernetes services. Obviously, you don't have access to the command line flags that will be running on the control plane. You don't get to kind of tweak those and kind of add in the bits you want, especially when it comes to things like authentication. So this is the sort of problem space that we're trying to solve with the tool. But before we kind of introduce the tool itself, there's a few things I want to kind of cover as we kind of go there. So the first thing is JSON web tokens that you may have heard of before. So they build on top of a JSON web string, which is a 3-part base64 encoded string containing a header, payload, and signature. So the header being kind of some extra information about how the token itself is signed, payload containing kind of arbitrary information you might store inside, and then the signature signed by some higher authority that can be kind of cryptographically verified, as it were, on the contents of that token. And then a JSON web token then defines some kind of JSON objects that are to be expected in that payload. And we can kind of build on top of these to kind of create these tokens that are used for identity and eventually OIDC. This will get on to later. So this is what a kind of typical JSON web token would look like, and if we decode that, you can see that we kind of have the objects inside and the kind of each attribute we have inside the payload here. So these are called claims, and they contain information about the holder of the token. So in this case, we have name, Christian, Simon here, and the groups that they belong to, but also who signed that token, who the token is for, the subject, etc. One thing I guess to note is that we also have an expiration date as well, which is means that these tokens aren't long-lived or could be short-lived, which is obviously a good kind of property to have, kind of dealing with kind of authentication, etc. So Moving on is OAuth or OAuth 2, I guess, which I'm sure we're probably all very familiar with, the kind of one-click sign-on features that you see across the internet. So right here, we have a case of meetup.com. And this generally is a really nice thing that's become very popular on the internet. And it allows us to kind of have our identity stored in some higher power that we all trust, for example, Google, maybe not so much Facebook, but hopefully Google, and we can share identities on multiple websites that we might not necessarily trust, but we definitely can trust Google. And if we do that single sign-on through Google, then we can share identities across multiple websites in a secure way, and kind of ensure what kind of information they have about us through our kind of consent through Google on those single sign-on. So these OAuths have multiple flows. This is one example of that flow, but generally the way this works is you'll have a resource owner. So in case that'd be me, logging into a client, which would be meetup.com, for example. And then if we have an auth provider for Google, for example. So I'll go to click onto meetup.com. Meetup.com will request against Google that someone wants to single sign on through Google. I'll then get forwarded on from meetup.com into Google. I'll then be presented with, the classic screen. Do you want to share your name and email, etc., with information with that website? Then they, once you say yes, they do that token exchange, and then once you've accepted that, the meetup.com can then request resources about your identity from Google. So it'll collate your email address, etc., and then you build that kind of user account on meetup.com, and that'll be a long-lived account tied to your Google account. So OpenID is built on this concept, and I'll show you the flow in a minute. But basically, by completing this OAuth flow and proving you have or proving your identity to some kind of service that you want to connect to, that service can then use that identity to build one of these JSON Web Tokens by filling in that payload with some identity about you, and then signing it itself and presenting that with you, and then you then have a bearer. You have the bearer of that token that you can use against that service that's cryptographically signed by the service and can be trusted. So a few OIDC implementations, Google offer this, Azure, or Opta, etc., and there's quite a number more. But we also have DEX, which is what I'm going to be using later on, and that's an open source implementation of it. And what's nice about DEX is you can connect multiple backends to DEX. So, for example, Google, Facebook, etc. But in this case, we'll be using GitHub later. So I'll be completing that overflow with GitHub, and then DEX will be the one signing my OIDC token and presenting with me. So if we take this the OIDC, it's fairly similar to overflow, I'd say. So if we take it into the kind of Kubernetes world, when the Kubernetes API server starts up, if it will be configured in such a way, it will first do a discovery against the OIDC provider. And this discovery, it's basically hitting a well-known endpoint, which it will discover the public keys that will be used to sign the JSON Web Tokens. Then as a resource owner, I'll come along, consent to that OIDC provider. I'll get sent back my JSON Web Token containing my user information and cryptographically signed. And then throughout the kind of the life of that token, I'm able to request or make a request to the API server using just that token. And what's nice about this is that the Kubernetes API server doesn't need to make more calls to the auth provider, to the OIDC issuer, because it can cryptographically verify that token throughout. So yeah, the API server in this case only needs to make that one discovery call at the beginning, and then throughout it can just verify the token at every call, which is quite nice. So we covered sort of OIDC and the others. If we quickly touch on authentication and authorization in Kubernetes. So if we kind of delve into what a request to the API server might look like, in Kubernetes, they split authentication, authorization, etc., into different layers. So when a user makes a request to the API server, first of all, it goes through the authentication layer. And in the case of OIDC, what that means is going to be verifying that JSON Web Token that we showed earlier, extracting the username of groups, etc., and yeah, creating that identity. It will then go to the authorization layer. So if you imagine that this user is going kubectl get pods, and the user Alice is trying to do that, then the authorization layer will kind of verify whether the user Alice in group XYZ is able to get pods, and then reject if not, and then pass through. Another thing to note is the feature of impersonation in Kubernetes, which will become important in a second. But Kubernetes has a feature where if you can add these impersonation headers onto HTTP requests, and they allow you to impersonate other users or groups in your kind of authorization layer. Yeah, cool. So if we move on to KUBE-OIDC-PROXY, where does this all fit in, and why is this all important? So as we spoke about earlier, about having these managed Kubernetes services, not having access to the control plane, etc. We can't fiddle with the flags, and indeed we can't have consistent identity across the clouds. What we can do instead is introduce a reverse proxy into our cluster, which is going to be doing the OIDC authentication for us, and then by validating that request, they can do impersonation on our user. And what that means is we're effectively kind of pulling that authentication layer outside of the cluster into the space that we control. So if we do the same flow again, Alice get pods, KUBE-OIDC-PROXY is going to be doing the OIDC verification of the token, and then building a clone of that request, and then putting those impersonation headers based on the contents of that token, and then passing it on to the API server. So once it goes onto the API server here, the authentication is going to verify that it will be using the KUBE-OIDC-PROXY service account. So at this point, it's the KUBE-OIDC-PROXY service account trying to get pods, impersonating Alice. And then at the authorization layer, it's going to check whether KUBE-OIDC-PROXY can impersonate, and then again, whether Alice can get pods, and then onwards. Cool. So another point of reference, point to note. So the KUBE-OIDC-PROXY, if the OIDC validation fails, it will obviously return a 401. But other kind of trip ups, if our token that we try to request with doesn't have a username that KUBE-OIDC-PROXY can use to impersonate, then we'll have to do a 403. And indeed, if the user is using impersonation during their request, then we'll have to do a 403 as well. And that's based on the fact that Kubernetes doesn't allow you to stack your impersonation. So you can't impersonate Alice, impersonate Bob, impersonate Charlie, for example. It's just not a mechanism that it can do. So yeah, you'll have to disable impersonation headers in this way. Cool. So what does this mean? It kind of ticks all the boxes with the problems we were having before, right? So we have consistent IAM for all our providers. So we control the identity that we're bringing to the cluster. Therefore, we can bring it, make it consistent across all our clusters and all our clouds. We have no more lock-in due to virtue that we control the identity in this case. Integration with existing systems. So if you're pulling identity from on-premise, for example, then you can bring that identity with you and hook it up in that way. Consistent RBAC again, users are the same identity across different clusters, and of course it's multiple, fully customizable. It being kind of in our kind of a domain rather than hidden behind a managed service like GKE or EKS. The feature set kind of added onto this. It implements auditing, of course, very important, especially if your OIDC is failing at the KUBE-OIDC-PROXY, because that won't get exposed on the API server side. So yeah, we'll leave the auditing there. It has kind of allowance for using service accounts against the KUBE-OIDC-PROXY as well. So that would be the Kubernetes service accounts will also work, and extra impersonations metrics to be released in the next update, as well as disabling impersonation. So in the demo I'll be showing later, this reverse proxy doesn't always have to be used against Kubernetes API server itself. It can be used as a generic OIDC reverse proxy, which is quite neat. Cool. So yeah, like I said, I will be showing a demo. So just to run through what I'll be showing you first. So I have cert-manager running, managing my TLS certificates contour, using that as the ingress controller. So I'm using TLS pass-through for this as well, just to keep traffic encrypted between KUBE-OIDC-PROXY and DEX and such. DEX to implement the OIDC, which is connecting to GitHub. Gangway, which is a nice web UI for building the kubeconfig once I've authenticated myself. Nginx, which is just running as a simple HTTP server as a landing page. So we have nice clicky buttons, clicking which cloud you want to go to, and KUBE-OIDC-PROXY for the Auth. Cool. So we'll be running in 3 clouds. So GKE, EKS, and DigitalOcean. You can see we're running Gangway and KUBE-OIDC-PROXY in each of the clouds, but you'll notice that we only have 1 DEX running. And that's because all of the proxies are using the same OIDC issuer. They can share that, but when you're authenticating against each one, your kubeconfig that you'll get back will contain audiences for different KUBE-OIDC proxies. Why that's important is that your token needs to be valid against just a single audience. You can imagine a scenario where if you had a single kubeconfig or a single JSON or OIDC token that was valid for all your different clouds, as soon as that token would get stolen, or one KUBE-OIDC proxy would get taken over or some such, any requests that they receive could be used against all of the clusters. So by using kind of the audience claim, you can scope the kind of blast radius of those kind of scenarios. Cool. Yeah, standards using Terraform to spin up on my infrastructure. I'm using JSONnet for the Kubernetes manifests themselves. So instead of something like Customize or Helm, this is quite nice. Once you get it working, I think there's kind of quite a lot of work that needs to be done, or a lot to get your head around to get it working properly and understand the kind of nuances of what it's trying to do. But once you build sort of libraries around the kind of objects you want to build, you can end up with some quite nice, very minimal functions that, like minimally described, a very kind of complex object. So it's quite nice for building those abstractions, but yeah, it can be tricky to get used to, I'd say, and quite a big time investment as well. Cool. Yeah, and this is just an example of the KUBE-OIDC-PROXY running as a kind of generic Auth proxy. So I've got a unsecured HTTP server listening on localhost, running in a pod, and then I'm using KUBE-OIDC-PROXY running in a sidecar, pointing to that localhost, and that's receiving traffic from a load balancer. Cool. So demo time. Hopefully it's not too laggy. You can see my screen. So this is the landing page. Fingers crossed. This is the landing page, and yeah, 3 clicky buttons. So I guess first we'll go to GKE. You notice here that we kind of changed our URL, so we're running on the Gangway on GKE. If we do sign in. So as mentioning before, DEX has these multiple connectors that you can access to. You can see the full list on the website. But yeah, so here we have email of GitHub. So if I click GitHub, you can see here I'm now forwarded onto GitHub's website. So DEX is requested for someone to be kind of authorized against GitHub to get their information, and then DEX is then forwarded me onto GitHub. So GitHub is now asking for my consent whether DEX wants to have access to my team membership or email address. So this is all public information anyway, so I'm happy to authorize myself. That looks good. So I'm back into DEX now. So what has happened there is I consented to GitHub for GitHub to give my identity to DEX. DEX has then taken that identity, and now it's ready to sign a JSON Web Token. So click that, and now Gangway is ready to give me a nice built kubeconfig. So if I take a look what's just downloaded, you can see it's built a kubeconfig here with a cluster that is pointed to GKE, the KUBE-OIDC-PROXY running inside, and then includes the ID token, which is the OIDC token, along with the issuer that signed it. If we take a look inside here very quickly, you can see that the kind of claims inside hold the identity of myself, and there's my email address. And just to show, if I get pods, you can see there. Oh, you can see there that everything is fine. It's all connected. But of course, if I try to do something like get secrets, for example, my forbidden username joshua@gmail.com, which is my GitHub username, is not authenticated, not authorized to get secrets in this cluster. Yeah, so that's it basically. We can try again as well onto AWS, for example, do the same thing, log in with GitHub. And what you'll notice here is that I didn't have to complete the OAuth flow again, because I've already done the OAuth flow once with Dex, and I have a session with Dex at the moment. Dex already has that identity about me. It just needs to sign the token again for the next kind of proxy that I'm going to be connecting to. So I can download the second KUBE-config, and again, this one is pointed to the EKS cluster. And similarly, if I click that, I can look inside the cluster, and that's all fine. And I guess for completeness, I can show that if I try to run as foo, for example, I will get the error message that we're expecting that impersonation is disabled for KUBE-OIDC-PROXY. Finally, to show you the kind of generic proxying behavior that we can do, you can see that we have the HTTP server running here, and it's running the KUBE-OIDC-PROXY as a sidecar. I can curl this using an ID token that I've generated, that I've requested from Dex, and of course, if I authenticate with that, then everything is fine. Again, if I somehow break the token, then I get that unauthorized. So even kind of unsecured generic backends, we can secure using KUBE-OIDC using this proxy. So it's pretty cool. Cool. I don't think I've missed anything. Go to the next slide. So yeah, as I said, this can, cool. So this is the URL. Please feel free to try it yourself and log in and download the KUBE-config and have a look around. Everyone should be able to OAuth through to their GitHub account, and everyone should have access to it, read-only access. So feel free to play around with it if you so desire. Yeah, if you find anything, any leaks or any way to kind of get any bad information that you shouldn't have, then do send me a private message. But yeah, for future developments of the project. So there was a recent point where dynamic authentication config was, as a proposal to Kubernetes was made, whereby you could control the kind of OIDC configuration that we were talking about earlier on the kind of API server flags, configuring that using Kubernetes resources, but ended up getting closed, mostly due to the fact that the Kubernetes project generally has concerns around the separation of concerns for control plane configuration, as well as generic kind of Kubernetes resource configuration, so the workloads. So there isn't a great separation between, you know, describing your workloads, for example, and describing how to authenticate to Kubernetes. So that ended up getting closed, but that could have been kind of an avenue of the kind of project being deprecated, and this being a lot easier for people, and indeed, you know, for the multi-cloud case specifically as well. What would also be very cool is, since we have keys to the castle, as it were, something like exec locking would be quite beneficial. So since we're proxying every request that's going into the API server from a user, we could then potentially also record exec sessions and do playbacks, which would be very helpful for things like auditing, things like that, and being compliant. So yeah, that's like on the roadmap, I guess, of something that I'd like to explore and do, but indeed, that's a very hard problem to solve. Yeah, it's a tricky problem. Cool. That's all from me, really. Yeah, again, there's the web URL. If you want to try it out for yourself, there's the GitHub, and yeah, thank you very much.
Good stuff. Sorry, I was just trying to log into your cluster there, and I think my kubectl is too old, so I had a bit of a problem.
Oh no.
But I was just randomly copying and pasting things. That's what they say, isn't it? On the internet, you should always copy and paste things you find on the internet into your shell, and nothing bad will ever happen. Right?
Indeed, absolutely.
Especially if it's a guy called
Please
Josh,
log into this.
we just
Yeah.
met. Yeah. So brilliant. Thank you, Josh. And you know, big thanks for making it real by doing the demo. Yeah, we sacrificed something to the demo gods, and it all went really nicely. So thank you. I do think it's it really adds to a talk to be able to do a live demo. Okay, so questions. Yes, so we got one from David. Are you all right to take a couple of questions, Josh?
Oh yeah, no, absolutely. Sorry, I forgot to mention that at the end. Yeah, no, of course, definitely. Yeah.
Cool. Sorry. Yeah, I often go pile straight into questions, and for some people, it's that they don't want to do it because it's I think sometimes the questions are the hardest bit.
Yeah.
So, question from David: can the OIDC-PROXY be used to control authentication to the or authorization to the Kubernetes dashboard?
Yeah, that's a really good question. So I've definitely had this before, and long and short, no. So for things that are in your web browser, you want to use something like Auth proxy. So the kind of authentication method is different there. So when you're kind of connecting to your Kubernetes dashboard, that's sort of your kind of web HTTP, and you ought to be using kind of session tokens that are kind of you know, valid for your browser, and using something like Auth2 would kind of facilitate that. Yeah, so the KUBE-OIDC-PROXY is more for OIDC, and that's, you know, more for kind of applications identity, or indeed kind of using your CLI in that way. So yeah. Otherwise it'd be a very big pain to make sure that your web browser is sending those error tokens in the headers and such. So yeah.
Okay, cool, good. Thank you, Josh. Question just coming from John. Oh, that's quite a long one. So he says the dynamic credentials and token mentioned can be tricky. I noticed GKE now has a rotating short-term token by default, good for just a few minutes. It tends to break tools that don't support token rotation. Does this work on cloud native Kubernetes options where you don't get to manage the control plane? So I'm not sure if that's two questions in one. That might be a little bit too much to answer.
No, it's
offhand.
Okay. It tends to break tools that don't support.
Have a look. Yeah, cool.
Indeed. So in terms of does this work on cloud native where you don't manage the control plane? Yes, definitely. So the KUBE-OIDC-PROXY itself, authenticating to Kubernetes, uses a Kubernetes service account, and that is all handled transparently for you. So that side of the proxy is fine. In terms of kind of connecting to the proxy itself, so kubectl, you probably saw when I printed out the kubeconfig has these refresh tokens, which are slightly longer lived tokens, of which you can use to kind of refresh your token. kubectl should be taking care of that for you. But indeed, since we have the kind of, we control all of this OIDC flow, you are able to kind of configure that the way you want. So you'd be able to set how long you want the token to be valid for. Indeed, the kind of best practice would be to have short-lived tokens as kind of short as feasibly possible. But yeah, if you were so desired, you could make them more longer term. And yeah.
Okay, great.
So I hope that answers the question.
I think so. I hope so. John, does it answer the question?
Yeah, thank you. Sorry for the loaded question. It's kind of convoluted, but I ran into this issue just a little bit about a week ago, and it broke all kinds of my stuff because the tokens decided they needed to rotate. So yeah, appreciate it.
Cool.
Yeah, no worries. Yeah, it's always a tricky problem. Like you try to make something more secure and then everything then breaks.
Okay. Anybody got any other questions for Josh before we wrap up? Going once, going twice, going 3 times. Okay, well, in that case, I just say, panelists, if you want to just come off mute and open your video, and give Josh a little round of applause. I just want to say thank you very much to Josh for very interesting talking, good questions, and lots of things to play with. So thank you.